the idea is we're going to be using exactly what we spoke about here. Nothing is going to change. And the one thing that should comfort you is the fact that with these parabola questions, right, they won't get any difficult than this. They won't give you graphs that are like moved up and down and all that, fortunately.
Okay.
Yeah, they'll always be rounded like this, either a negative parabola or a positive parabola.
Yeah.
Yeah.
Which is nice.
Yeah, definitely. You know, so you should just make sure to always get these marks like without fail, because they're always like that. You know, they don't have any other way to ask these questions at grade 12 level. So with what you have here, right, they told you that given the function f of x, and they have restricted the domain. You see, that's what this is saying. This is saying they have restricted the domain. So the domain has been restricted to just this part, the part that's bigger than 0. So they're saying write down the range of f. So remember, even though down here is where they're asking us to sketch the graph, I mean, you don't need to wait that long for you to already visualize this image, for you to get help easier. Because we already know that with everything we're doing, right? This is a parabola, right?
Yes.
Yes, and we know that it's a smiling parabola where it's as basic as it gets. So meaning we have an image that's starting from here. Now, instead of us drawing a full graph that has one left side and one right side, we know this is saying we should only consider x values that are bigger than 0. So automatically we know we should remove this side. Now this is the picture we have. So looking at this picture, what is the range of this picture?
Why?
Like what are the?
Is
Yeah, go on.
The greater than equal to 0.
Yes, y is bigger or equal to 0, 100%. That's marks we should never lose, you see. So A, we're going to say y is bigger or equal to 0 because the y values start from here going all the way to infinity. And then now they're asking for the equation of the inverse. What can we do?
So then you swap your x and y.
Yes, you swap your x and your y, and then you do what after you swap them?
Yeah, so you have you square root it, so then it'll become square root x equals y.
Okay. Okay, so I think what you're trying to say is we swap the x and the y.
Yeah.
And then we make y the subject of the formula.
Yes, and then you square root it.
Okay, so to make y the subject of the formula, saying we should square root this side, then we should square root this side. Okay, perfect. And then now we have y
equals
is equal to square root of x. But remember, because there's a square root, you have to put plus or minus here, of which as a final answer, we have to choose what to put because we cannot put both. You see, this is where your knowledge of this work comes in, because remember, we are trying to get the inverse of this graph, right? So automatically you should know that, okay, fine, we have a line of inverse here. Your line of inverse is like your biggest weapon, because remember, this line of inverse, right? If we're going to choose what you call, remember, this is saying y is equal to something specific. So just because there's a square root here, you see, we already know that x is always going to be a positive number. So we know that whatever comes out here is a positive number. However, we need to put a sign here that will correspond with what our inverse will look like. So as we said already, our inverse, we always just need to look at the line of symmetry. So if we have a small curve on this tiny part, we should have one there. And then that will guide us to draw the rest. So now you can see that your y values are always positive, you see.
Yeah.
We are not dealing with the one down there, we're dealing with the one up there. So if you know your y values are always a positive, then instead of you putting plus or minus here, you can just choose the plus as the one you put there, because the plus and the minus is trying to take into account how you will have a curve up here and a curve down here if you have no domain restricted. But then because we have a domain restricted here, we cannot draw both curves. We cannot have plus or minus. We only have to have the plus, which is the positive y values, instead of considering the negative ones as well. Because this is saying your y values are equal to positive this or negative this. You get?
Yes, got it.
Noise. So for C, they want us to sketch the graphs of f and the inverse on the same set of axes, show the line of symmetry. We've already done that, you see, and you might as well do it also for yourself long before they ask for it. You can just even do it somewhere somewhere in your answer sheet, because it will always help if you have it beforehand even to answer your questions better. So we can just label it now. This is the inverse. This is the original one. Even if they don't eventually ask you to sketch it, it doesn't matter. Sketching it has its own merits because it makes our life easier, much easier.
Yeah.
Cool.
Cool.
So for D, let's see what D is asking for. D says G is the reflection of F in the x-axis. This one is quite interesting. So let's maybe copy this whole thing, right? So that we don't have too much going on in like one image. Let me copy this. Let's paste it down here. Down here, so down here, so down by the river, blah 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 blah. Where's this thing now? So this is D. So with D, let's see what they're talking about. Let me even copy this thing so we don't have to keep scrolling up, down, left, right. We just can stick to the bottom here. Let me see. D is saying G is the reflection of F in the x-axis. So we have to answer the following questions, right? They say G is a reflection of F in the x-axis. So we are talking about F, right? So let's actually even remove this here because we don't need it. We don't also need our line of inverse here because we're not talking about inverse. We're talking about the y-axis. So we have the y-axis, which is this line here. This is our y-axis. G is a reflection of F in the y-axis. So if G is a reflection of F, can you see where G is going to be?
Well, it makes, because they state in the y-axis, so then x becomes a negative. So
these x values here, we will see them.
Either being quadrant 2 or 3.
Well, 2, because this is quadrant 1, 2, right? So yeah. remember that there's the reason why we drew this pink line is so that we can say, okay, it's a reflection of F in the y-axis. So the same way we work with the reflection about the line y is equal to x is the same way we work with this reflection about the y-axis, because what you see on this side, we should just see on the other side. So if you have an arrow here, you should see an arrow here as well. If you have a curve that looks like this here, then you should have one that looks like that there. Do you see?
Yeah.
So this is f of x, and this is g of x. You see, it looks like one full graph here, but we know it's not. There's a portion of f here, and then its reflection is a new graph, which is g. So they're asking for the equation of g, which is the first question. Now, the fortunate thing is, remember, the equation of g and f, you don't want to confuse it and think it's something different. The only difference is the restriction. It's because this here is what makes the graph of f. Us changing this will make the graph of g, you see, because what we already know is g is just also x squared. However, we know that our x values need to be smaller or equal to 0.
Is it because the x becomes a negative?
Yes, because remember, this is x, the positive side of the x-axis.
Yeah.
This is the negative side of the x-axis. You see, positive, negative. It's just flipped over. Now,
yeah.
you,
Sorry, the other day I struggled to understand why it changed. Like I couldn't, didn't make sense why it changed. Now it makes sense because it's a different graph, and that graph is moved, so it changes.
yeah.
Okay.
Yeah, when
Got
you think of it like that, it's okay. We should just remember that it's still just going to have the equation x squared. But then we should only consider the negative side where the x values are below 0.
So Levi, do you still just leave it as x squared, or do you write it with a negative x squared?
No, you leave it like this because remember, that's a good question. So if you look at the equation of f of x, do you see that f of x is x squared? However, they are saying only consider x values that are bigger or equal to 0. What that means is in a Cartesian plane, automatically you're only going to be throwing positive x values, meaning when you plot it, right? Remember, it's all about what happens when you plot. Remember, this is positive 1, 2, 3, 4, 5, 6, 7, 8, going on and on and on. So remember, in your equation, you're going to be throwing positive 1 there, which is going to give you a 1. Then you plot. Then you throw positive 2, it's going to be 4. And then you plot. Then you throw positive 3, it's going to give you a 9. Then you plot. By the time you're done, you have a picture like this one. You see, because you're only plotting x values that are bigger than 0. With this graph of g, right? Remember, you have a Cartesian plane, and this is saying only consider x values that are below 0, meaning you're going to throw an x value of -1 here, right? So you remember, you're going to be putting these x values now, -1, 2, 3, 4, 5, going on. So when you put -1, it's going to come out as 1. So you put a 1 there. When you put -2, it's going to be -2 squared, which is still a 4. And then -3 squared, which is still a 9. -4 squared, which is still a 16. And then you'll draw your image like that.
And it also states the reflection, so okay.
Yeah, which is still going to be the reflection. But the issue is, the only trick here is that, okay, wait a minute, it's still the same graph, but then we just have to consider x values that are negative now. So instead of us writing a negative here, we only just need to put this there. You see?
Okay. Now that happens all the time, right? Like all.
Yeah. Yep. This is where we need to read our question nicely. Because remember, these questions are not trying to trick us or anything. They're just trying to help us stay awake. Because remember, if you put a negative x squared here, when you, it won't, this will be now saying that your values that come out here, you're always going to take the negative. So meaning you're actually going to be drawing your image down here, because this will always come out as a
inverse of it.
This is more like a reflection, what you may call, about the x-axis. You see, so you're gonna reflect about the x-axis. It's yeah, it's definitely a mission now. You see, so so yeah, with this kind of a question, yeah, you just wanna keep things nice and simple. I think for this question in particular, right? I think let's maybe even expand a bit more on what could be an what you call an accepted answer. Well, I think what we've said is enough, really, because if you really try and psychoanalyze it and you think of you know, doing anything else for this kind of a question, yeah, it's gonna be a bit strange. But what you can do is for D, what did they write for D1? Because I think there's a memo for this exercise.
Yeah, for D1, they wrote it just like that.
Perfect.
Yeah. So the way we have it, it's just like that. See, so I'm most probably thinking of the inverse. That's why I'm asking, why isn't there a negative? Because when it becomes the inverse, it will become a negative square root x. So
let's, because well, I think when you're thinking of the inverse, remember, it's going to be y is equal to negative x under square root. Yes, 100%. Which is why we have plus of.
Yeah. Sorry, and then when you actually do the one that we just calculated, it eventually actually becomes a negative x to the power of 2. And then negative times a negative becomes a positive. That's why it stays a positive.
And then its inverse is the one that will look like this with a negative, the inverse of g.
Yeah.
So that's 100% fine.
Yeah.
So you see here, them asking us to get the equation of the inverse. What we know is, because we have, this is the original graph, right? And we said that x becomes y becomes x. And this is actually kind of important to always write out. It's more like a way to communicate with the examiner so that they will know that, okay, fine, y becomes x becomes y. And then we said there we need to square root both sides. So you're going to square root the y here, square root the x there. And then you're going to have y here is equal to plus or minus square root of x. And then you have to choose one. So you see here now we're choosing the one with a negative x.
Yes,
for the inverse.
The inverse.
Yeah, because we know that, as we said already, if this is the line of inverse, right? This is going up like that. So the arrow here will need to be like somewhere there. You see, so we'll have to throw a curve like that, of which this is under the x-axis. So you see, those are negative x values over there.
This actually makes it so much easier.
Negative y values, sorry. Yeah, dope.
Because what happens is I would always have to calculate the coordinates and then I would get so confused.
Yeah, that's more like, yeah.
You still have to, but then you don't have to like figure out the other coordinates because you can just do what you just did now. So.
Perfect. So with now sketching the graphs, looks like we just did that already. The graph of G, sketch the graph of G and its inverse together on a new set of axes and show the line of symmetry. So it's just going to look like this. See, we don't have to worry about F. F is not in the question right now. This is what it's going to look like. Graph of G looks like that. Its inverse looks like that.
Yes.
Yeah. And that's that with these kinds of questions. You see, they'll always seem like there's something special about them. But the idea is to actually keep our thinking very simple. You know, because sometimes they'll just be using different names for the graphs, but we can see that, okay, wait a minute, this is actually just drawing the other side if there was no restriction.
Yeah.
So that's all that's happening here.
No, that makes sense.